Hey everyone. Back. Yeah, time for another Toolbox Tech Talk. Welcome everyone. Good to have you here. And look, probably time I took my sunglasses off because I can't see a thing with these on. Well, a lot's been happening. It's pretty exciting. So there's been the All Energy show in Melbourne for the last week, and I've been there both kind of as a content creator, but also with my company Solar Plus, which is solar design software. So yeah, I've been kind of juggling those two. But today, what have we got on the agenda for today? Well, let's look at it. So I'm going to keep it kind of pretty basic, really. I'm doing a little spot on labeling of systems. Now, labeling of systems has been one of those areas where there's been a lot of confusion, partly driven by the fact that standards have not helped. Standards have been all over the shop when it comes to what label goes where. But we've got a lot better. In fact, with the latest 4777 Part 1, the inverter installation standard, we've really aligned our labeling a lot more with other renewable standards and with Aeson ZS3000. So things are getting better. But there's still kind of some legacy labels out there that people have got used to putting on, which are actually inappropriate, confusing, and even wrong. So I'm going to talk a bit about those. I'm also going to take questions from the audience. So right now, if you got a question, put it in the chat. Now, if you're new to live stream, there'll be a chat option somewhere on your screen. And if you just want to type some questions in there, that'd be great. Even better, just say hi and where you're from. I'd like to know how widespread my audience is. So yeah, join in the chat, please. That would be great. So first up, All Energy. Now, for those who are not familiar, All Energy is probably the biggest renewable energy show in town, well, in Australia. Each year it's held in Melbourne, has been at the Melbourne Convention and Exhibition Centre, commonly referred to as Jeff's Shed. That's another long story. But yeah, it's a big show. It's the other big show, of course, is the Smart Energy Expo. It's been held in Sydney, which is doesn't a different time of the year. So the Smart Energy Expo was back in, I think, April this year. So those are two big events. But anyway, All Energy was last week on Wednesday and Thursday. As a exhibitor there, it's a lot of work. Bumping in and bumping out, getting your booth ready, going to all the events, mostly late in the evening, late in the afternoon through to the evening. So the big one for installers, of course, is solar cutters. So big hats off to solar cutters here. This is my apple juice. It's kind of a big celebration of the community that is solar installers and solar people in general. So yeah, that's quite a big event on the Tuesday night. Great, so I can see a few people have joined the live stream once again. Just maybe shout out to me, where you're from, in the chat. I'd love to know who's listening and how far my reach is. Of course, this live stream is available afterwards as a non-live event. You can just watch it on my YouTube channel. Anyway, so yeah, All Energy. What was hot? And what was even hotter, this year it felt big. I think there was something like 10,000 people on the first day. And yes, JC86 says, hey Glenn, what's your top 3 favourite things from All Energy? So definitely going to run through my some things that I was really excited by, including what I'd call my top few. Now, at these shows, there's often a lot of stuff that you've already seen before. So a lot of brands that we all love are often featured at these shows. And that means you get to meet the people, maybe the support techs that you've been talking to, and also learn new stuff about their new products. But then there's also all the new kids on the block. So new manufacturers who are bringing new products. So yeah, it's pretty exciting. I tend to, when I do my booth interviews, and I did actually have a list of 46 booths to visit. I think I got through about slightly less than half that. So apologies to booths that I didn't get to. I need a whole week of All Energy to get around that place. It's just so much to see, so many people to talk to. and so much good information. So yeah, I'm going to run through some of those products. So yep, just for those who just joined, please feel free to type in the chat, say hi, where you're from, any questions you've got that you'd like me to cover in this live stream. So what I'm going to do is I've made a bunch of videos already that are up on my channel, and I'm going to sort of talk about the products that are associated with them. And so if you're not familiar with my channel, it's the Smart Energy Lab. See if I can bring it up here. So that's that one there. There we go. So, oops, that's not it. That's not what I've been seeing lately. Okay, here we go. Yeah, so some of the videos that I've made in the last couple of days from the All Energy show, and see if I can get the right view. There we go. It's just taking a moment to refresh these. So there's things like Aeson. The Aeson, Melbourne-based company manufacturing batteries, including sodium ion. I'm going to talk a bit about them. Solinteg, which is a hybrid inverter company from China who make big hybrid inverters, and I've actually had some of their units here. In fact, I've got one of their 20 kilowatt hybrids as an off-grid EV charging system here at my lab. Of course, Pylontech, who's been in Australia for over 10 years providing battery storage solutions, but now they've actually got an all-in-one system, so we'll kind of look at that. Redback Technologies. Now, there was kind of a moment there we thought Redback were going to disappear. They had a few business troubles, but actually they're back. And Redback are back with new products, which is great. So, great Australian brand, Redback. Solis, of course, I think the third biggest inverter manufacturer in the world. Solis featured some of their new hybrid inverters, in fact, with some great features. I'll talk a bit about those. In terms of Australian content, Excess. Excess is an Australian company that was formed by AERL and Craig Hunter. Now, Craig, for those who are not familiar with him, is a bit of an icon in the industry, been involved in the industry for over 25 years with companies like SI Clean Energy and Selectronic. But now he's actually formed as he's a co-owner of Excess, and Excess are making some really innovative off-grid systems, so we'll talk a bit about those. So there you go, those are already up on my channel. There'll be probably another half a dozen or more going up over the next few days. So let's have a little look at some of them more precisely. So Solis. Now, Solis is, hang on, so I've got my iPad set up, there we go, that's better. Solis, like I said, is actually the third biggest inverter manufacturer in the world. So there was a lot of Solis product at the show. But I'm going to focus on two particular products that I've been involved in, been making a installation video on the new Solis 8K hybrid. And there's also their three-phase hybrid as well. So just checking the chat here. Hey, JC86, thanks for engaging. Yeah, he says, don't think I actually got engaged with half of what I wanted to see. Spent the full days there as well. So JC, yeah, there's just too much to see. In fact, there's a lot of walking around. I try before the crowds arrive on the first morning, because I'm an exhibitor. It means I can get in before the public get in. I run around with my Insta360 camera on a long pole and try and sort of capture the whole place. But I didn't even have time to go right around all the avenues, all the aisles, because it's so big. Yeah. Now, just a side note too about this live stream. Last week when I launched it, there was a few people complaining about buffering. Now, I looked into that, and it turns out it's actually your problem, not my problem. How's that for an answer? It sounds like a support company. So because the bandwidth is streaming live from my system. It's coming out at the moment about 5 megabits a second. YouTube can't do all the optimization they do normally with a recorded video that's uploaded, because when you upload a video to YouTube to be viewed in perpetuity, they make a whole lot of different compressions, different scales, and so the YouTube software automatically adjusts to suit your bandwidth. But in a live stream, they don't have that ability because there's no time. It's basically live. So, and unfortunately, if your bandwidth limited a little bit, there will be some buffering. I can't do anything about that. So sorry. But of course, if you get a bit frustrated with the buffering, you can always watch this later on after it's been optimized by YouTube and becomes part of my permanent collection of videos on the channel. So anyway, back to Solis. So let's see if I can find what I'm after. The Solis hybrid inverters. Okay, I'm scrolling through them here. I better go to the top and look for products. Okay, our products. So I'm just scrolling through their web page at the moment. Energy storage inverters. There we go. And it looks like actually they haven't put it up yet. Oh, there you go. That's funny. So the one at the show, I guess it's so new that they haven't got it on their website, is an 8 kilowatt hybrid. Now, what's special about it? There's a bunch of things. For a start, it's called the 8 kilowatt hybrid plus, but then the plus means it's got an extra AC port. It's got a generator port. What's that for? Well, it means that if you're a grid-connected system with a battery storage and some PV connected, you've essentially got three forms of energy. You've got solar during the day, you've got battery whenever you need it, and you've got the grid when it's available. But during extended outages, when the grid's not available and it's nighttime, depending on the capacity of your battery system, you might just run out of battery. Now, if you want the ultimate in reliability, having a backup generator is a great idea, and that can be integrated directly into the generator port on the 8 kilowatt hybrid plus. So it's got a third AC port. So that's one unique feature. It also has a very big oversizing ratio. So that means even though it's an 8 kilowatt AC output inverter, it can have 200% that, so 16 kilowatts of PV connected to it. And you might think, well, that's a waste. Well, no, because it can walk and chew gum, which it means it can charge a battery and invert and support loads at the same time. So that's pretty cool. So being able to do that means having lots of solar. You can supply up to 8 kilowatts to your loads and any surplus to the grid, as well as charging your battery system. So yeah, more solar, always a good thing. And of course, certainly for those of us who live in the southern states, every day isn't a sunny day. And on a less than a perfect day, your 16 kilowatts of solar might be only putting out 4 or 5. So it just means that you're always getting a high solar fraction from your inverter. So that's another thing. Oversizing is really big. The unit that I've got here in the lab has a screen, one of the beautiful big Solis screens. But I believe they're actually debating whether to bring the screen or the screenless version out first in Australia. So they may come out with the screenless version first and then bring out the screen version if it's in demand. Now, this is one of those debates between engineers, manufacturers, and end users and installers, because, as an installer, I love a screen. It's great for checking and monitoring the system without having to get an app out. Customers like screens generally because it's easy to review the operation of the system without having to have a phone in your hand. But then again, manufacturers aren't so keen on screens because they're often one of the weak points in a system. Like, for instance, water ingress, fading due to UV, or even just manufacturing faults mean that the screen may not work or be degraded. But it has no impact on the performance of the system, yet it's a warranty replacement. So it kind of adds a risk factor, and it also adds cost. So, yep, the pros and cons of screens. The Solis 8 kilowatt hybrid can be connected via Wi-Fi to your home Wi-Fi network, via Bluetooth directly from the app on your phone, which really, I like that. There's no mucking around with trying to remember the password, etc. Or if you're an installer, trying to get the customer to find their Wi-Fi password. That's often half the joy. It can be connected via wired Ethernet. In fact, one of the dongle options is one that's both Wi-Fi and has an Ethernet port on the bottom. So you can wired Ethernet, which of course is in a way the most reliable internet connection. So it gives you all four. So wired, wireless, Bluetooth, and there is options for a 4G, a separate device, I believe. I haven't actually tried it. So lots of options there. Another feature is that you can parallel these. Now, what does that mean? Well, it means if you've got one 8K, 8 kilowatt Solis inverter, you can actually have 2, 3, 4, 5, 6 of them. And they can all parallel on the same phase. So that means you can build a much bigger system out of multiple Solis inverters. And they have a kind of manager-worker relationship. So that means one manages the other 5 in terms of export, limiting, etc. So that's a pretty cool feature. So there you go, in single phase and 3-phase. So in 3-phase, you have 6 per phase. So that's a total of 18 inverters. You better have a big garage if you want to go for the full shebang. G'day, George. George from Tasmania, I guess, if you're still there, George. enjoying the warmer weather at the moment. It's a great thing. I'm not sure if you got across to Melbourne for All Energy, but I'm doing a bit of review of All Energy at the moment. And George, yeah, right. You're at Cutters, great. I did the world's fastest tour of the Cutters event. I actually had a lot of other events to go to, so I literally ran through the crowd, holding my camera above my head, did a quick swirl around and out the door again. So I'm not sure if you saw me looking rather stupid running around, but there you go. I did actually make a short video out of it and post it on my channel too, just to give the vibe of Cutters. And for those who are not familiar what we're talking about, Solar Cutters it started off in 2017 just as a Facebook group, as a kind of industry self-help private group where people helped each other with challenges and problems. And it was all kind of small and nichey, but now it's got very big. In fact, they run road shows now. So thanks to Costa, it's become a major training organisation by providing training to the solar community through roadshows around Australia. Yeah, sorry, George, you missed me. You're probably too busy enjoying a beer. So I've got my apple juice here. Right. Okay, so that was Solis. Now, I only just touched on the single-phase inverter, which can be configured as 3 of them for 3-phase, but they also had their big hybrid, which comes in, struggling with my memory now, I think it goes from 8 to, oh boy, I'm struggling. If it was 15 or 20 kilowatts, but anyway, or even more, might have been 50. But anyway, they've got a big 3-phase hybrid with the same features, so it's got a generator port as well. I mean, I wish I could just bring it up on this webpage, but it's so new they haven't got it on their webpage, I don't think, so I couldn't find it in a hurry. So yeah, they're large 3-phase unit, and the single-phase unit uses nominal 48-volt batteries, which is great. It's got a really high charge and discharge current of 190 amps, but the 3-phase one uses high-voltage batteries, which better suits the DC bus of a 3-phase system. Okay, so that was Solis. It's going through them now. Excess. See if I can get it a bit bigger. There we go. Excess. So Excess was formed, or Excess Energy to be precise, was formed by Craig Hunter and Peter Watkinson. So Peter Watkinson, the CEO of AERL. I love to mention this every time I say their name, but AERL are the OG of MPPTs. They invented, well, I should say, they made the first commercially available MPPT. There were theoretical designs before that, but Peter's dad, Stuart Watkinson, in 1983 made the first commercially available MPPT. In fact, I've got one on the shelf behind me. I actually had one. In 1991, I bought my first one. And it was a big deal because that meant we weren't locked into having PV arrays that had the same nominal voltage as our battery system. So if you had a 12-volt system, you wanted nominally 12-volt panels, 36-cell panels. If you had a 24-volt system, you had two 12-volt panels in series, or sometimes you could get a 72-cell module, which was 24-volt. But when you went to 48-volt systems, you had to have combinations of panels to get there. But without maximum power point tracking, you were reliant on the battery voltage determining the operating voltage of the PV array. Now, this is probably a moment I could rock out a little diagram, because I've got a little drawing set up here, and let me see if I can get it working. So let's go to, there we go, bring that in, bring that over. So why are MPPTs a big deal, and what's the advantage? Well, maybe I'll give you a little bit of history to start with. The earliest systems were incredibly simple. And when I say earliest, we're talking the 1970s and before. You basically had just a switch connected to a battery. So there's your battery, and there's a switch, and that was it. That was your charge control system. So let's say you had a 12-volt battery here, and your panel would be a 36-cell, or sometimes even a 32-cell module. Because 32 cells never puts out enough voltage to overcharge a 12-volt battery. It's a really kind of lame solution, but that was a thing. Then along came something a bit smarter, which was still a switch, but it was a semiconductor switch. So this here looks like the same thing, but instead of a mechanical switch, it's usually a MOSFET. And so this will be a MOSFET, which is a semiconductor device, and it would be switching at kilohertz, so at really high frequency, on and off. Now, what's the benefit of doing this? You've got a 12-volt battery, still got your same PV module characteristics, something like a 36-cell panel, but what it meant is it could, if I do a time versus current graph here, on, off, on, off, on, off, on, off. And it adjusted what's known as the Mark-Space ratio between on and off. So this is current here, and this is time here. Now, what that does is mean the average amount of current is going up like this. So the average amount of current going into the battery. Now, of course, that can be for like slow, soft charging, maybe for a battery that's very depleted, but also it can do the reverse. When a battery is full, it will, I should say that's a red for I, when a battery is full, it can taper off the charge and not increase the voltage beyond its manufacturer's recommendation. So that's known as a pulse width modulation. So this is known as PWM, and it's still around. In fact, PWM is extremely cheap and simple. If you go to, say, boating, fishing, camping, and buy yourself a little so-called regulator, it will be about the size of a matchbox and goes on the back of the solar panel, and it's doing exactly this. It's ensuring that the battery is not being overcharged. So it's very cheap to make, very simple. But the problem is that you've now locked the solar panel to the battery voltage. So here's another little explainer. So let's show an IV curve. So that's current voltage of a solar panel. We call this an IV curve. Okay, and it's the load line. So down here, this will be open circuit, and this would be short circuit. But a solar panel produces power. The sum of current and voltage will give you power. And so it's got a power curve that looks like this. And so here is our maximum power point, the point at which we get the maximum power. And if I was to drop that down here, we would have a voltage at maximum power. Now, let's say we've got a 36 cell module. It'll have a VOC of about 22 volts. Okay, and it'll have a VMP of about 17 volts. Now, if we connect this panel to a 12-volt battery, a 12-volt battery is going to determine the operating point on the curve, because the battery is the immutable force. It's not going to rise up to 17 volts in a hurry. It's basically trying to clamp the voltage to its voltage. So we'll put 12 volts here. So there's my 12-volt battery, which means that I'm effectively operating at this point here on the power curve. So instead of putting out, let's say it's 150 watts, if I run this across here, it might only be 100 watts. So my 150 watt panel's only putting out 100 watts when the battery's at 12 volts. Now, it actually gets worse. Of course, when the battery's just about empty, it might be 10.5 volts. And so we're operating way down here, and that means our power could be like 80 watts. So when you most need the grunt to charge a flat battery, you're getting the least amount of power of your solar panel. And conversely, when you least need grunt to charge your battery when it's nearly full and it's up here somewhere around about 14 volts, you actually got the most power. So that's one of the disadvantages of PWM. It's not a good match to the power curve of a solar panel. Okay, that's quite a lot of theory I've just given you. Well, maybe I'll just take you on to MPPT land, because we were talking about XS and AERL and their MPPTs. So what's different about an MPPT? Well, and why was it such a big deal that Stuart Watkinson invented one? Well, let's once again draw one of these IV curves. There we go. So VOC, ISC, okay, and I'll draw the power curve. So here's my power curve, like this. And this is the maximum power point. So on the IV curve, we would call this the maximum power point, to be exact. So the sum of voltage and current will give us a VMP, voltage at maximum power, and also a current at maximum power. Now, what a maximum power point tracking charge controller does, so the T for tracking, is it seems very simple. I mean, things like a matchbox took a while to invent, a paperclip. Well, so did an MPPT, but actually it was a bit more clever than just a matchbox or a paperclip. Was when a solar charge controller or inverter first sees light, it starts up here. It starts at open circuit. So it can see voltage on the coming off the PV array. So what it does is it starts to draw current, and as it starts to draw current into the charger, the voltage starts to drop and the current starts to increase. So it's tracking along this curve, the IV curve. It's also known as a load line. And at some point, it gets to the maximum power point, but it doesn't know it's there until it's gone too far. It's gone too far, and so it turns around and comes back. So actually what it does all day long is tracking the point at which the sum of voltage and current give it the most power. So that's what we call a maximum power point tracker. There you go. And it took Stuart Watkinson in 1983, a young electrical engineer from Queensland, to come up with a commercial device that did exactly this. Woohoo, Australia. I mean, Australia's known for its innovation. We invented the stump jump plough, the humidity crib, and the maximum power point tracker. Also Wi-Fi. That was a good one. Yeah, so go Australia. There you go. So back to XS. So where are we? Back to XS. So XS have inside their unit the AERL MPPTs. In fact, you can have multiples of them. They're expandable. So I think you can have one or two. So each one's roughly 5 kilowatts of power. And the other thing about their MPPTs is they can operate at high PV voltages. So up to 600 volts, I believe. So high input voltage from a PV array, which is fairly unique. I mean, not exactly unique. Victron with the RS450, Morningstar and Schneider also have some high voltage MPPTs, but there's not many out there on the market. Another big plus for the AERL MPPT is that it's got earth fault detection built in. Now, this is actually a requirement in Australia. In our grid PV array standard 5033, any systems over 60 volts, any systems over 120 volts, I should correct myself there, require earth fault alarm function. And to do that, you need to detect an earth fault. So if you've got a DC coupled charger, solar panel, charger, and connected directly to the battery, that device must be able to detect an earth leakage. Now, there's very few products on the market that can do this. So Victron RS450 does, I think the Morningstar, Schneider, and AERL, they're the 4 that I know of, but it's quite a limited group. So if you don't use one of those devices, then you actually have to buy an external earth fault detection device, which costs probably as much as your MPPT. So there you go. So George is having a bit of glitchy feed from Tasmania. Sorry, it's a long way down there. Yeah, so what else is inside this box? There are some power conversion devices. Now, I think I'm okay telling you this because it's pretty obvious if you open the box. They're actually made by a company called CE plus T, which is actually one of the oldest power conversion companies in the world. CE plus T celebrated their 90th birthday this year. They haven't been making inverters for 90 years, but they've been in the power industry for 90 years. So this Belgium company, very well known in the telecommunication space for their products. And they make hot swappable modular inverters. They're a 2RU form factor, and you can basically pull them out while they're running. If you've got more than one, you don't lose power. You just lose maximum power proportional to the number of power converters that are left behind. But one of the really big features of the power converters is that they actually are decoupled from the grid. So if you've got a grid or a generator input, they are charging a battery and then separately inverting from that battery. That means you can have dirty generator power feeding your home and have clean AC power coming out the other side. So it's like it basically is a UPS type system. But it also means, and this is a big plus for people who are on any feed-in tariffs or restricted by their lines company, DNSP or utility, whatever you want to call them, it is not a grid paralleling inverter. So it's using the grid purely to charge batteries. So it's one-way device. And therefore, if you've already got a PV system, let's say your DNSP let you put in a 5 kilowatt inverter, and they said, that's it, you can't have any more capacity. Well, you can add one of these because it's not a grid paralleling inverter. It's just a battery charger. There's no regulations on how big your battery charger can be. So that's a great plus. And also for off-grid applications, it means that even poor quality backup generators will still mean you have clean power in your home. So that's a huge plus. So yeah, excess in that box there's up to 4 of their 2.4 kilowatt inverters and 2 of the AERL 5 kilowatt MPPTs. And I believe you can have up to 5 or more of these units. So you can build quite a big system paralleled onto their battery system. And there's a nice picture of Craig Hunter. And I think they might have a picture of their batteries somewhere. No, I have to go to products. Products, there we go. Energy storage. So they also have their own lithium-ion battery called XS Ion. There it is. So it's a rack-mounted cabinet-based system, and it's fully DC coupled to the XS unit itself. So that's pretty cool. Okay, just checking. Yes, stream's going well here. Okay, so that's XS. What's next from All Energy? For those who just joined, I'm doing a bit of a review of All Energy in Melbourne from last week. I was there making videos, and so I've already published about half a dozen of them onto my channel. We've covered Solis, XS. let's go on to Pylontech. Now, Pylontech, it's a Chinese battery company who've been in Australia for over 10 years. So they're really well known in Australia and globally, of course. Pylontech make a wide range of lithium-ion battery solutions, everything from your small 2RU, 3RU rack-mounted batteries, the US 2000, 3000, 5000s, etc. Also stackable batteries, so they're high voltage ones like the Force H1, H2, and now the Force H3X. Now, what's the big deal about the X? The X is an all-in-one system. And so the big plus about the X is, see if I can get a picture of it coming up here, is that no longer you have to get someone else's inverter, it's built in. So that black thing at the top is the inverter, so it's a hybrid inverter, but they also do an AC coupled variant, and they use their own battery technology. So each battery stack is another 5 kilowatt hour, and you can stack, I think, up to 15 in one stack, so it's 15 kilowatt hours it is, so 3 batteries in one stack, and the inverter goes on top. Now the inverter has an enormous display. It's not very clear from this picture. I'm not sure if we can zoom in a bit. There we go. But you certainly know what your battery percentage is from maybe 10 meters away. A very, very elegant looking display. It's sort of like a plastic glass front. I'm not sure which it is, but it's very shiny. So yeah, elegant looking and all-in-one. The big plus with all-in-one, of course, is you're dealing with one company, and it's a very simple installation because you don't have compatibility issues or comms cables. You're basically just connecting it out of the box. I call it the IKEA-like solution, where it's all pre-designed and you just assemble it on site. So that's a big move for Pylontech with their all-in-one. They were also showcasing their CNI systems, and so they've got some nice big CNI units there. See if that's going to come up in a sec. So for those who are not familiar with the acronym commercial and industrial, basically we've kind of got 3 market segments. We talk about residential, people's homes, CNI, businesses, and that means it's generally behind the meter systems, and then utility, which is in front of the meter. And utilities generally large scale, megawatts capacity. So, boy, it's taking a long time to load. Well, here we go. I better have another sip of my apple juice. For those who are watching at the moment, shout out to me where you're from in the chat. I'd love to know who's watching at the moment, who's watching live, and if you've got any questions, whether it's about what I'm showing you at the moment or anything related to solar and batteries, go for it. So there we go. That's the Pylontech CNI system. Now, I saw a lot of similar systems at the conference, and it's because there is a booming market, particularly in China, funnily enough, for CNI. There's some government incentives because of power reliability. Certainly in some of the new development areas where factories are being built, there's maybe not quite the infrastructure to support the increase in loads. And so these kind of systems, your sort of 100 kilowatt hour and up storage systems, are very popular. They're also becoming popular in Australia, maybe not so much for intermittency of supply, but also because of peak demand charges. If you're not familiar with what peak demand is, if you're a large energy customer, often you'll be given a maximum supply, and if you exceed that maximum supply target, you get a penalty price, which basically holds for the rest of your billing period. So on day 1 of your billing period, if you shoot your peak for more than, I think it's 30 minutes, you pay that penalty price for the next 30 days. And it means that the maximum demand charge can be your main charge on your cost of electricity, but it's only a small amount for a short period of time of energy. Now, this is not networks trying to dud you over. They're basically trying to limit maximum demand by using a financial disincentive for shooting your maximum demand. Now, adding a system like this means that maybe even just for 5 minutes, it's capturing that that small peak. It doesn't have to supply the whole factory. It might just supply the peak, and that could be quite a small amount of power and energy, and that protects you from that maximum demand charge. So yeah, that's another reason. So that's Pylontech. Shout out to Ned Yu. He's the APAC manager for Pylontech and has been with them the whole time. So I've known Ned for over 10 years now. So well done, mate. Okay, Redback. Redback Technology, Australian company, founded, I think, probably about 10 years ago. I'm trying to remember the date. And what they did was introduce one of the first all-in-one systems to the Australian market. And it was a bit of a revolution that we had one box to rule them all. Basically, batteries, an inverter, and smart energy management in the box. Now, recently, Redback did have some challenges with their business and were momentarily sort of on hold, I think, and they have a new owner and they're back. And they're back with some good and exciting products. So they've got new single phase and 3-phase inverters and using the same beautiful design all in one with the Redback Smarts behind it. So it's not just a hybrid inverter, it's an energy management system. I've had their Gen 1 and Gen 2 systems here at the lab for ever since they came out. And yeah, the Gen 2, really great. These, I guess, are the Gen 3s. Looking forward to having a play with the Gen 3s. So yeah, welcome back, Redback. Not that you went away, but there you go. Now, someone asked at the beginning of my live stream, what were some of my high points of the show? Well, I guess I look for new stuff, and this company, Aeson, Aeson's a Melbourne-based company. In fact, they're going to be starting to manufacture batteries in Melbourne. Now, there is some Victorian incentives for manufacture here, so I guess that's why they've chosen Victoria. But what I was excited about is the fact that they started manufacturing sodium-ion batteries. Now, we're all familiar with lithium-ion, and if you know the periodic chart, the next down from lithium is sodium. So it's got similar characteristics to lithium, maybe not quite as energy dense, but it's got a lot of pluses. And the pluses are, to make a sodium-ion battery, you don't need cobalt, you don't need copper, so it's actually cheaper to make. It's also got inherently a higher threshold for thermal runaway, like 800 degrees, I believe. So it takes a lot of damage for this unit to go into thermal runaway, so it's safer. Also, sodium is the 5th most abundant element on the planet. We're not running out of sodium, unlike lithium, which is really restricted to just less than a dozen sites around the world that have access to lithium mines, including Australia, China, Bolivia. These are limited resources. So sodium takes away that worry about resource scarcity and probably means a more stable price. Another plus is, and I've got a sodium-ion battery here from another company, Nation Energy, the Feridian cells are in it, and I presume that the Aeson sodium batteries are much the same, is that they can be fully discharged with no risk. I mean 0 volts, not 2.1 volts per cell, but 0 volts per cell without harm. So they can be shipped as a safe product with no energy in it at 0 volts. And it also means that you don't have to worry about self-discharge killing your battery, which can be a problem for a lithium battery that is being left off for a long period of time. Now, Aeson are starting small. They're starting actually with automotive batteries, so basically a 12-volt car battery, but it's sodium-ioned. Why? Well, one of the challenges of putting a non-lead-acid battery under the bonnet of your car is it's a very hot environment. And people have tried to put lithium-ion batteries in. 2 problems. One is the maximum temperature for a lithium-ion is typically 55, 60 degrees, and it gets much hotter than that under the car. The other thing is the cranking amps. So be able to get really high cranking amps without the BMS kicking in. Those have been a bit of a challenge too for lithium. But sodium-ion, 85 degrees. So they can handle up to 85 degrees Celsius, and their small 12-volt sodium-ion battery gives you 750 cranking amps. That means its peak current to start an engine is really high. So that's awesome. So there you go, Aeson, Melbourne-based company making sodium-ion batteries, starting small, and then they're going to move up the value chain to larger applications. They also do lithium-ion and even lead-acid as well. Okay, so I like to pick some that I've had associations with, and so Solinteg. Solinteg is a Chinese inverter manufacturer who make inverters, hybrid inverters, and they also make string inverters, but really their focus is on hybrid inverters. They make big hybrid inverters. So I've got a 20 kilowatt three-phase hybrid inverter here, and that's their small one. Yeah. You can currently get a 50 kilowatts, and soon there'll be 100 and 100 plus, I think 125 kilowatt three-phase hybrid inverter. So one of the features of the Solinteg hybrid inverters is that you can group them, so you can have like 10 of them managed by one of the 10, so it can build very big systems using multiples and multiple battery stacks. But for off-grid applications, they've got this pretty unique feature where you can actually parallel their backup circuits. So that means that if you've got 5 20 kilowatt inverters, you can parallel the backup circuits to give you 100 kilowatts of backup power. That's awesome. So yeah, Solinteg, I've actually been to their factory in Wuxi. Wonderful people to hang out with and to learn about their product. So they're a small manufacturer, but very quality and great support. So there you go, Solinteg. That was my pick for big hybrid inverters. Anker. Now, Anker, for me, I knew the brand through their power banks and small power supplies for laptops and other devices, and they were really quite well known for the quality. So Anker is like a premium manufacturer of power banks and power adapters. In fact, their power adapters use technology known as gallium arsenide. Now, normally switching electronics is done with silicon, but gallium has a lower on resistance and therefore less heat, and it means that their little chargers are tiny, almost half the size of a conventional charger for the same power. So really high power in a small footprint. But you know, there's always a few giveaways at a show, and this is one that I really liked. And see if I can bring the overhead for you. And I'm just gonna get the app open. And where are we? Overhead. Okay. So this is the Anker Prime. So it's a power bank, kind of chunky looking thing. And the reason it's so chunky is because it's so powerful. It can put out 250 watts. That means I can charge 2 powerful laptops directly off the USB-C ports on the top here. It's also got USB-A as well. And it's got a Bluetooth built in. You can turn that on and off, or have it auto off. And so I'm currently linked to it with my phone, so I can actually see the capacity, but I can control it. So that's a really cool little power bank, and it's 99 watt hours, so you can take it on a plane, and it even comes with an optional docking station, so you can just wirelessly charge your power bank as well. So there you go. That was pretty cool. But that's actually not what I was really excited about. It was, if I go back to the Anker page, is Anker Solis. Anker Solis is their home energy storage solutions, the X1. So they do a hybrid and an AC coupled unit, and they bring with it the aesthetic of their home electronics, which is beautiful design, great features, and very easy to install. So we've just installed one here at the Smart Energy Lab, and it's comes with all the components without any on-site manufacturer. You basically just follow the instructions, place the battery modules one on top of the other, the inverter on the top, and connect the battery cables on the side. one of the features I liked about it was that the batteries have their own DC converter on each battery, and that means that each battery can be charged and discharged at a different amount. And you might have, say, 2 batteries to start with, and a couple of years later you add a third, but the third one's brand new, so it's got a bit more capacity. No problem. The DC-DC converter means that it works independently and can still give all of its capacity to the inverter. So it means upgrades are problem-free, and it also means you get all of the juice out of a battery module, irrespective of its capacity. Welcome, Tradie Trev. Yeah. Keep standards free. Yep. So Tradie Trev, I guess you know about the Smart Energy Council's Smart Installer program, which for free you can sign up. And for free you can get 15 of the essential solar and battery standards. It's worth over $5,000 and it's free. And there's no catch. There's no hidden costs or ongoing fees. It's free from log in, sign up for free, and off you go. You won't be inundated with spam emails either. And why is it free? It's because the Smart Energy Council found some sponsors to sponsor the cost of those standards. And they did a deal with Standards New Zealand, who are very amenable to reasonable priced standards. In fact, out of the box, the half the price or less of Australian standards for the very same one. The only difference is the cover. Every word inside is the same. Go figure. So if you're new to the debacle of Australian standards, it was sold off to a private entity way back in the 80s. It's gone through numerous owners, and currently, last time I looked, it was a Swedish investment company that owned Standards Australia, listed on the Australian Stock Exchange. So they're a business whose primary objective is to make value for their shareholders by selling standards. There you go. Okay, so back to Anker. So the Anker Solis Hybrid and AC coupled unit. Let's have a look. Products. Okay, learn more about the X1. Seem to have a rather slow connection on my iPad for some reason. But yeah, there you go. That's pretty cool. That's the Anker new range of installed energy storage systems. So they were big in the portable power, in fact, portable power stations as well, and now they're big in the home energy storage market. So expect to see those being distributed in Australia very soon. Okay, next up. What have we got next up? In fact, I think this is the last of my web reviews, is a company called Green ESS. Now, I didn't manage to get to their booth. In fact, I had quite a few people who were disappointed, and big apologies. I never managed to get to their booths, but Reynold actually said to me, why don't I come to you? So he came out yesterday to talk to me about Green ESS. And to tell you the truth, I thought it would be yet another hybrid inverter, maybe with a battery. And how wrong was I? How very wrong was I? So Green ESS have come up with a very, very innovative idea. And let me show you. I've got a miniature Lego version of their product. I thought this was pretty cool. Here we go. This is it. This is the Lego version. This is basically a scaled down version of it. Now you might go, oh yeah, okay, so Glenn, it's a inverter and a battery in a box. Well, actually it's so much more. That sounds like something from a TV show. So we've got in the top section here, a inverter, so I think it's 5 kilowatts. I'm not 100% sure. I'm actually going to be doing an install video shortly on this unit, and then we've got a power management module in here, which allows it to work with a range of different inverters. So the inverter at the moment is OEM. It's not actually their inverter, and because they've got their own power management in here, they can change which inverters they choose to use. But the clever part is what's in these two sections, these two halves. In this half, we've got two, I think they're 5 kilowatt hour battery modules, which are permanently installed. But in this half, we've got removable power banks. Yeah, and I've got one right here. And this is the actual unit. So this thing here is a 48 volt 4 amp hour unit, so it's 192 watt hours. So you're not going to be taking this on a plane. You might go, well, why would you have, in fact, there's, I think, 6 or 12, depending which model you get, of these built into the green ESS. And this part here is a little add-on module. If I pull it off, this bit is what goes into your home energy storage system. And why? Why have we got a removable battery? Because this can power a whole family of devices. Now, behind me, I don't know if it's actually visible. Let's have a look. There's a scooter. Over here, there's a scooter, the Jasper. And what do you know? It's actually powered by this battery. So for a start, I can pull one of these out, put it in my scooter, and off I go. And when I've finished, I'll pop it back into my, my BESS, and it will charge it up. But this same battery can be used with power tools, with lawn mowers, line cutters, chainsaws, e-bikes, and with little add-on devices like this. We've got high-powered USB, even got a little light. So I guess it's about portable power as part of a home energy storage system, not just a fixed unit on your wall. So really interesting design. And these batteries will be able to be used as part of your charge and discharge cycles too. So they're not just a charge up and stay charged. They're actually part of your usable capacity, and you, through the app, you can determine when they're going to be fully charged as well. So let's say you plan to go camping and you want to make sure that all of your camping devices powered by these batteries have full batteries. You just program that by the time you're going camping, all of these are fully charged. So there you go. Green ESS, really, really interesting concept and interesting product. So that was the one I didn't get to. That was the one that got away, is green ESS. So you'll probably see more when I've got the actual unit here and get to play with it. So there you go. Now, just checking if there's any questions. No more questions in the chat there. Now, we're coming up to 2 o'clock. We're going to finish pretty shortly. So if you've got any questions, make sure you throw them in at me. Now, I did say I'd touch on labels, and I'm just going to bring that up. Okay, let's have a look. Okay, so here we're looking at a label. So this is in many label kits. It says battery, and it lists the chemistry. Now, it's a requirement for any battery system that's installed under 5139, the battery standard, which is for installation of battery systems over 1 kilowatt hour, up to 200 kilowatt hours, over 12 volts, up to 1500 volts. So pretty much every residential and CNI system. And even if you've got a system that's over 200 kilowatt hours, if per unit it's 200 kilowatt hours. So if, say you've got 5 200 kilowatt hour units, you've got a megawatt hour system, each of them is still covered by this standard. And in Victoria, I believe Energy Safety Victoria consider it appropriate for utility as well. So you've got to check what the regulator says. But anyway, you've got to have the UN number displayed, but it needs to be on the ES sign. It needs to be on this sign. And this sign is the appropriate place to have the UN number. The ES sign needs to be at the main switchboard, the switchboard to which the system's connected, and or the fire services panel, if there is one. This sign here is not mentioned in the battery standard. So you're perfectly welcome to put it up, but it's not required. So there you go. Now, onto a more prevalent one is this one, risk of battery explosion. So risk of battery explosion is about explosive gases. And in the standard it says some lithium batteries, and I'm talking about lithium because it is probably the most dominant technology, may release hydrogen in fault conditions. How do you know? Well, that's what a safety data sheet is for. You should check with the manufacturer's safety data sheet if there is a risk of explosion from the release of hydrogen. But there are battery types which don't release any hydrogen and can't because the chemistry is such. So you might have, say, a zinc bromine battery. So zinc bromine is a flow battery. Companies like Redflow make them. There is no hydrogen being produced in any condition. So you don't automatically slap up a risk of battery explosion on every system. You need to ensure that it is actually a real risk. Now, toxic fume hazard. Table 3.1 in the battery standards lists lithium-ion batteries as having a toxic fume hazard under fault, and I agree. And so does ESV, which is the main fund for Victoria. Don't challenge them. The fact is that lithium-ion batteries contain lithium hexafluorophosphate as their electrolyte, and in thermal runaway conditions, what tends to happen is the lithium hexafluorophosphate will be released under pressure, the cells will rupture, the pressure release valve will open, and out comes what looks like an innocuous white gas, sort of fog, a white fog. But actually that white fog is turns into hydrogen fluoride with contact with moist air, which is basically air with any moisture content. So you've now got hydrogen fluoride gas, which hydrofluoric acid, which is what it is one of the most corrosive organic acids that is known. It will strip the lining out of your lungs if you breathe it in. So yes, it is definitely a hazard. So this sign is required on lithium-ion batteries or any other batteries that release toxic fumes, and it should include the PPE requirements and warnings. So for instance, in case of fire, evacuate and wear the appropriate PPE if you are entering the space. So there's various PPE signs. I'm just showing protective clothing. That's more likely arc flash, but breathing apparatus. And it should list what the nature of that PPE is. Once again, that's where you review the safety data sheet. It should tell you what the toxicities are, and those signs are appropriate. We got rid of the rooftop isolator in Australia, but not really. You're still quite able to use rooftop isolators, but for 2 strings or less, you can use the disconnection point option, which basically means there's no isolator on the roof other than the plug and sockets that you already installed. They need to be adjacent to each other, so the most positive and most negative need to be adjacent to each other. They need to be within 150 mils of the edge of the module, and this sign needs to be visible on approach on the edge of the module. And the actual where are we? Cables themselves and conduits need to be labeled solar DC, and I think there's a little tag somewhere. Where are we? That's not it. That's not it. That's not it. Having trouble finding it. Okay, this little sign needs to be attached to the points of disconnection. So it's a warning that loads must be isolated and circuit must be tested for the absence of current before unplugging. It's electrical work to unplug it. It's not an emergency switch. So that's now a valid option in Australia, and it's always been an option in New Zealand because they realised what a bad idea rooftop isolators were. Now we've come to the end of the time for this live stream. I've actually had quite a bit more content to say about signs, but I think that'll have to wait to my next live stream. So I think I might have to skip a week because of some personal events that are happening, but I'll announce them via my various socials every time I'm doing another Sunday live stream. So once again, thank you everyone for turning up on a Sunday afternoon to watch this live stream and contributing, and yeah, keep safe. Till next time. Okay, out.